Hello students, my name is Shashank Shekhar and today is the sixth lecture of the chapter Amines. We have covered all about amines. Now we will move to diazonium salt. Today we will be talking about this part, that is diazonium salt. We have been introduced to this diazonium salt in the alkyl halide chapter, or I would say haloalkane and haloarine. So there we have seen that for the preparation of fluorobenzene, we used this diazonium salt because it was very difficult for any other process to do so. So we use the diazonium salt, and I would say that this diazonium salt cannot only be used for halides, but can be used for multiple, or you can say multifunctional groups. Okay, so you can introduce a variety of functional groups using this diazonium salt. So talking about diazonium salt, we will first see the preparation and the chemical reactions related to it. Okay, and its importance in the synthesis of organic chemistry. We will also look at stability and all. So if I talk about the topics that are to be covered, so first of all, we will look at what our diazonium salt looks like. Then we'll see what are the methods that can be used for the preparation of the diazonium salt. Further, we will move to the physical properties and the chemical properties. In chemical properties, we will see various types of reaction, starting from halide, means the removal of halide by cyanide, then by iodide, fluoride, simple hydrogen, OH group, NO2 group. Then after that, we will see the reaction involving retention of diazo group coupling reaction. So it is basically a coupling reaction that occurs with the help of your diazonium salt. We'll look at it also. At last, we'll just try to summarize that how this diazonium salt is important for the synthesis in the aromatic systems. So with this, let us start our today's lecture. First of all, what is a diazonium salt? So the myth I would be breaking right now is that the general formula that comes in your mind as soon as I tell the word diazonium salt is that your X here is being limited to Cl minus. But it is not so. Okay. So every diazonium salt does not have this structure, which is Rn2 and X plus. So if you say diazonium chloride, then it is okay by putting this Cl minus. But if I am simply saying diazonium salt, then we can have various salts. Diazonium means this azo here stands for the nitrogen. These two nitrogens are present here, and it is positively charged, so it is an ion. So diazonium salt. Now this salt can be coupled, means this N2 plus of this salt can be coupled with any electronegative species carrying a negative charge. We can have variety of those. Starting from the Cl minus, we can have, this is called diazonium chloride, diazonium bromide. We can have HSO4, which will be named as diazonium hydrogen sulfate, or it can be borosulfate. So we can have variety of diazonium salt. Do not limit your say vision in case of diazonium salt to chloride only. There are many more other than diazonium chloride which are mentioned here. So you can have Rn2 plus Cl minus, or you can have Rn2 plus Br minus, Rn2 plus HSO4 minus, or Rn2 plus BF4 minus. You can have each of these, or you can have many more. Okay, so they are all in the class of the diazonium salt. So your name will be diazonium chloride, diazonium hydrogen sulfate, and etc. Now this N2 plus group is called diazonium chloride. Okay, if it is N2 plus Cl minus, then it is called diazonium chloride, and if it is N2 plus HSO4 minus, then it is called benzene diazonium hydrogen sulfate. So as I have told you earlier, that if it is HSO4 minus, then it will be diazonium hydrogen sulfate. So this is called as diazonium salt. Now what is R here? That will be defined later. So if I am telling it benzene diazonium salt, then we will have a benzene like this. Means R will be equals to I would say R will be equals to benzene. But if I am simply saying diazonium, it does not mean that it will involve always benzene with it. So the definition should be quite clear in your mind. So if I am saying diazonium salt, we will have this general formula as R N2 plus X minus, when X minus can be species like Cl minus, Pr minus, HSO4 minus, BA4 minus, and so on. Now further, if I add benzene in place of R, we will say it as benzene diazonium salt. Now further, if we just specify the counter anion, that is your X minus, then its name will change. It will be benzene diazonium chloride or benzene diazonium hydrogen sulfate. So this is the structure of your benzene diazonium salt. Next, we'll see how this is stable, because it is ionic species. You can see very clearly how it is stable. So basically, the primary aliphatic amine, only they are stable. So this should be kept in mind, that your only primary aliphatic amine, not also secondary and tertiary, only primary aliphatic amine can only form the alkyl diazonium salt. And your primary aromatic amine can do so. But the primary aliphatic amines salts are not stable. They are unstable. They will quickly break down. So that should be kept in mind. We will see what is the degradation reaction related with it. But for now, just consider that only primary aromatic amine are stable, whereas primary aliphatic amine, although they are formed, they are unstable. Now how they are formed, and it is stable only for a short time. This is also very valid point, that is stable only for a short time and at a very low temperature, that is 273 Kelvin to 278 Kelvin. It can be converted to degrees Celsius also. That can be written as 0 degrees Celsius to 5 degrees Celsius. So it will be stable for a short time, plus it is stable at very low temperature. How is it prepared, we will see later, but this is the structure. So why is it stable in case of aromatic amine for some time? Although it is stable for some time, then why it's stable for some time also? It is simply due to your resonance hybrid, that is, or you can say the electron density that is delocalizing the charge on nitrogen and hence creating a stable intermediate. So you can see here that it is acting as an electron withdrawing group in this fashion. It's moving here, it's moving here. So it is moving here, creating a positive charge here. Again, this is moving here, creating a positive charge here. Again, this is moving here. Now this will further move here. This negative charge will move here and will again create this thing. So that is the reason why your primary aromatic amines are only stable and not your primary aliphatic amines. One more point, you cannot form secondary or tertiary diazonium salt. Okay, you cannot form your say diazonium salt with the help of secondary or tertiary amines. So this should be kept in mind. The reason it's simple, from its structure only you can see the structure, that you cannot have any group that is attached to nitrogen. It is only attached to one alkyl group and your nitrogen, other nitrogen. So this is about the stability. Now we are done with the definition of diazonium salt, that how does diazonium salt look. We have seen benzene diazonium salt, then we have seen place the say counter anion and seen the benzene diazonium chloride and all. Then we have moved to the stability and seen that your aliphatic amines are less stable than the aromatic amines, although aromatic is stable for some time also, but still it is more stable than the aliphatic amine due to the resonance stabilization of the positive charge of nitrogen. Now next we will move to methods of preparation. So what is methods of preparation? What are the methods of preparation? So till now only one method of preparation you will study. I have also known it from the alkyl halide chapter, that if you treat your amine, so here we have amine here, if you treat it with NaNO2 NHCl, okay, you treat it with NaNO2 or HCl, then at 0 to 5 degrees Celsius the temperature should be maintained so that it does not degrade quickly. Then it will result in the formation of benzene diazonium chloride plus NaCl plus 2 moles of water. Now this method is called as diazotization, in which we are converting our amine to diazonium salt. So it is called as diazotization. So here we have the nitrous acid. So sorry, sodium nitrite and hydrochloric acid. So they both react to form the nitrous acid. Okay. And this nitrous acid further reacts with your say amine to give the following diazonium salt. Now, due to its instability, the diazonium salt is generally stored and is immediately used after its preparation. So as I mentioned earlier, the diazonium salt is not stable; it quickly degrades, so it is used just after the preparation. Now, if you talk about the mechanism, how is it formed? So this is the way it is formed. So you have your aniline. Say you have your aniline. Okay, this aniline will have the lone pair. Now this is your nitrous acid. This is having a positive charge here. First of all, this lone pair will attack. And this will create a NO with positive charge on this nitrogen. This will go here and will create N and NO and H. Now there will be a IPT, that is an interproton transfer. So I am taking this abbreviation from NCERT only. It will move here. This will create N double bond N and O minus, which is now say satisfied by the H. No problem till now. Now what will happen? It will again be protonated and this water will leave and this will result in your diazonium, benzene diazonium. Here we will have a positive charge. Now the counter ion can be anything depending upon the acid that we are using to protonate it everywhere. Okay, it will depend upon the acid that we are using. The counterpart of that H plus will be coming up here as X minus. So this is the mechanism that is followed for the preparation of diazonium salt. Next, now let's look at the physical properties of the diazonium salt. So benzene diazonium chlorides are colorless crystalline solid in nature and they are readily soluble in water. The reason is very clear, because it is ionic in nature and it is polar, so it will be readily soluble in water. But it is stable in cold, but reacts with water when warmed. So if you just warm it a little also, then the H2O will just replace the N2 plus and Cl minus and will get hydroxy group. We'll look at the reaction. So it decomposes easily in dry state. Benzene diazonium fluoroborate is water insoluble and stable at room temperature. So this is very important. This fluoroborate is nothing but N2 plus and HBF4 minus. So this is fluoroborate. Now this is stable because it is water insoluble, so it is stable at room temperature. Otherwise it is not stable at room temperature and it should be kept in water and cold, the other diazonium salt, but this benzene diazonium borofluorate has no such compulsions. So we have seen HBF4 minus earlier also. This is your BF4 minus. Okay, it is talking about that, so same. Next, I will see some of the chemical reactions. So these chemical reactions are very important. They are asked to and fro in the examination by replacing different groups. So they can have the reaction involving displacement of nitrogen and also the retention of diazo group. So two can be possible. So we will see those reactions. First of all, let us see the removal of N2 plus here. So it is a very good leaving group. That is why this reaction is facilitated, because this N2 leaves very quickly and this increase in entropy, because we are releasing gas on one side by taking solid on the left side. So this reaction is very feasible because the entropy is increasing. Okay. Now the groups such as this Cl minus, Br minus, Cn, all can be replaced. All can be put here. So how do we do it? So first of all, let us look at the first class of reaction that are given here. Okay. So what are we doing? We are taking a salt of copper and we are treating it in the presence of HCl. So what it will give? It will give the corresponding chloride, bromide, and cyanide. Okay, clear? Now the second, so this all reactions are called as Sand-Meyer reaction. What are they called? You must have studied this reaction, Sand-Meyer reactions. Now the other set of reactions, the two reactions are called as Gutermann reactions. In this, rather using our copper salt, we use copper powder and uric acid. Then also we get the same thing, but along with this we get a side product, that is CuX. So for this reason we have to now separate it. So for this reason we use this mechanism in which only gas is produced and it is just fled away. Clear? So these are the two sets of reactions that can be used for the replacement of the halide group. Okay, so replacement by halide group or cyanide group. Now let us look at each of them. So if you want to replace this N2 plus Cl minus with I, then you have to treat with Ki. Okay. So iodine is not easily introduced in benzene directly, but when the diazonium salt is used, the potassium iodide benzene is formed. So this reaction is very useful. You can see that, as you can see here, because this is very difficult to introduce the iodine at this position at benzene. So what do? We use this diazonium chloride and it replaces your N2 plus Cl minus easily with this I and get your iodobenzene. Next is what we have to do is we have to introduce F. Now you cannot use anything simpler. You cannot use CuNHF, not possible. You have seen the reaction, there is no such reaction. You cannot use Cu2F2 and HCHF. This is also not feasible. So for that, what do? We first treat it with HbF4. Okay, we first treat it with HbF4. So on treating with HbF4, what will happen? We will get BF4 minus. Now further, if you heat it, then it will simply do a reaction that will be intramolecular, and this F minus will be donated onto Ar, and this N2 will leave, and we will have BF3 also. So you can see the reaction, it looks very easier. So we have this N2 plus and BF4 minus as the counter ion. So if a negative charge, it will be attacking here. This will come here and we will get your ARF, that is fluorobenzene, plus this BF3 and this N2. Clear? Got it? So this is the introduction of fluoride group. Now next, let us see how can we replace it with H. So for that we use a dehydrating agent like H3PO2 or CH3CH2OH. Okay, so we can use two of them. What do? So we treat we use certain mild reducing agent like hydrophosphorus acid or ethanol to reduce the diazonium salt to your arenes, and they themselves oxidize to phosphorus acid. So now this hydrophosphorus acid is now oxidized to phosphorus acid, and instead it is reducing your N2 plus and Cl minus to simple arene. Similarly, if you use ethanol will be reduced to oxidized to ethanol, and it will IR N2 plus and Cl minus is, so it will be Cl minus, sorry. This will be reduced to your aryl group. So these are the two reactions. This is very important because you are directly getting benzene. So if you can think it in a different way also. Suppose you are given a nitrobenzene and you are told to, okay, just convert it into your benzene. So first you will reduce an NO2 with the help of SN and HCl. That will reduce it to aniline. Then further you can just diazotize it, and upon diazotization just convert it into your ARH. So what I said is that suppose you have a nitrobenzene. Okay, so first what do? You do the reduction and reduce it to aniline. Once it is reduced to aniline, treat it with NaNO2 plus HCl in 0 to 5 degrees Celsius. That will convert this thing into N2 plus and Cl minus. Okay. Then what you will do? You will treat your diazonium salt with, say, C2H5OH. Then you will get your benzene attached to this, plus your ethanol and whatever the side product may be. But this is a very useful reaction. Next, what we can do, we can replace it with this hydroxyl group also. So for that, you have to just, as I've told you earlier, that if you warm it with water, you will simply get AROH. It is simply an attack of H2O and the release of N2 gas. So you have to rise up it to 283 Kelvin. So it is almost room temperature. You don't have to worry much about it. Now, next is a replacement of NO2 group. So for that, what you will do, you will first convert your diazonium salt into this N2 plus BF4 minus. And then you will treat it with NaNO2 and Cu. Okay. You have to do this reaction through this step. This will give you NO2, N2 and NaBF4. So in this way, you can replace your N2 plus Cl minus with NO2 group. Now this is the most important reaction, I would say, because in this this is a called coupling reaction. So in this reaction, you couple your say this 2 benzene ring along with this OH group by removing N2 plus and Cl minus. So you can have two types of substrate. You can have aniline also. You can have alcohol also. If you look at it, it is nothing but a simple electrophilic aromatic substitution. And the evidence is that, first evidence, if you look at it, although this is not very concrete evidence, but you can see that the para position hydrogen has been replaced. So this hydrogen is preferred than the other hydrogen. So if you have studied enough electrophilic aromatic substitution, you must have seen that in most of the cases, the major product is para product if it is going through the electrophilic aromatic substitution. So how does this reaction goes? So if you want the mechanism, we can do it. So first we have this benzene diazonium salt, or benzene diazonium chloride more appropriately, with a chlorine minus. Now it has a positive charge and your benzene is having a cloud of negative charge, and you have added this OH also to facilitate more electrons. Therefore, it will simply attack here. Okay, it will simply attack here and create this kind of intermediate. Okay, no problem. So it will move here and it will create a positive charge here. Clear? Now what will happen? You have a positive charge here. We have OH here. Now this H that is being here will be removed. And we will get your simple electrophilic aromatic substituted product, that is your coupled product. Similarly, if you have a NH2, it will also facilitate the flow of electron to the ring and will make the ring electron rich. So again, we will use this N2 plus and Cl minus. If you treat it with, say, your NH2, that is aniline, it will again attack here. Next, what will happen? We have NH2. Again, this H will leave and you will get your coupled product. We have coupled this both rings. Now both of these have some functionality which is very unique. So if you have OH group, then it will give orange dye, orange color dye. But if you have your aniline group here, then it will give yellow dye. This is called para-amino azobenzene. This is called para-hydroxy azobenzene. Similarly, the reaction of diazonium salt with aniline yields p-aminobenzene. This is an example of electrophilic aromatic substitution, and it is being mentioned here also. Now, next we will move to some important diazonium salt that are used for the synthesis of aromatic compound. So clearly from the above reaction, we have seen that we can use various of the reagent and convert our diazonium salt to various aromatic systems. Say we can have fluorine, we can have chlorine attached also, we can have bromine attached also, iodine also, cyanide, OH minus and NO2. Now aryl fluorides and iodides cannot be prepared by direct halogenation. So therefore this method is very useful. Similarly, the cyano group cannot be introduced by nucleophilic substitution because nucleophilic substitution is not allowed. So therefore this method is again used. But cyanobenzene can be easily obtained from diazonium salt. So it is written here. Thus, the replacement of diazo group by other group is very helpful in preparing those substituted aromatic compound which cannot be prepared by direct substitution in benzene or substituted benzene. So by which I mean that it is very helpful in preparation of diazo group, means diazonium, means other functional group substitution, because we can use various substrate reagent that cannot be substituted easily if we try the simple electrophilic aromatic substitution, or even if we try nucleophilic, it is not possible for benzene to undergo nucleophilic aromatic substitution. So for that reason, this is very important. Diazonium salt is very important. So this was for today's class. So what we have studied today is that basically we have seen what is diazonium salt, in which we have clearly tried to put a distinction between what a diazonium salt is and what a benzene diazonium chloride salt is. So diazonium salt is something which is having a alkyl chain attached to R, N2 plus and X minus. Now if you just introduce R as benzene, then it will be called as benzene diazonium salt. Now if you replace X with something, say Cl minus, then it will be termed as benzene diazonium chloride. Okay. Then we have seen the stability. So it is not, the alkyl amine is not stable, it quickly degrades. The aryl one is stable because of the aromatic system that is stabilizing through the resonance effect. Okay, but that is also stable in cold water and for a few minutes. Further, we move to the preparation methods in which we have seen that if we treat it with sodium, say NaNO2 and HCl at 0 to 5 degrees Celsius, then it will undergo a complex reaction mechanism, I would say, to give your benzene diazonium chloride. Further, we have seen how various groups can be introduced. So I would suggest some important one here. So I would suggest the important one is this one, in which we introduce NO2. Okay. So for that, it was not direct removal of NO2, N2 to NO2. First, we have treated it with HbF4. So once it is converted, okay, once it is converted to this thing, then we have heated it, okay, to get our fluorine. Sorry, this is for fluorine. Okay. So for nitro also, the process was not simple. We have done something different. That was not usual one. Okay. So we have N2 plus Cl minus. So first we have treated with HbF4 to get this thing, and again with CuNO2 to get NO2 at NO2 at N2 plus and Cl minus position. Okay. One more reaction that was important, it was the reaction of Ki. So if you treat it with Ki, then that would result in iodobenzene. So you can see that various functional group can be prepared, and water hydroxy can also be introduced. It will just warm it with water, then you will get hydroxy here. Then you treat it with, say, C2H5OH, or you can treat it with H3PO4, H3PO2. Then also it will be converted to benzene directly. So this is, you can see here that various reactions can be done to convert the diazonium salt into important aromatic compound. So therefore, I would suggest you that you get a hold of all of these reactions in which you use benzene diazonium chloride for the preparation of various functional groups. Now this was all about your say amines. Now in the next class, we'll be starting with a new chapter. This was for today's class. Thank you.